show you another try it at home experiment, and this is one that is perhaps my favorite because it's wide open. There's all kinds of different things you can try. It turns out lots of teas and lots of juices that are brightly colored, the molecules that make them brightly colored react to the presence of acids and bases. And we're going to do some experiments with this. And I'm going to bring on Rachel, who is going to do a couple of different experiments with these different liquids. But I'm just going to set it up, and I'm going to show you what we have. And what we've picked is just a selection of juices and a selection of teas. But you can pick anything. I would say look in the cabinet, with your parents' permission, of course, and work with I want to choose like non-caffeinated teas, like herbal teas that are brightly colored, and juices that are brightly colored. So I've got some hot water here, and I'm going to make some hibiscus tea. And hibiscus tea has this lovely rosy tint to it. And I'm going to make one for experiment and one for a control, because we're trying to do this scientifically. And then I'm going to make turmeric tea, and turmeric tea has got this lovely yellow shade to it. And so we're looking for those bright colors. Smells nice too. That's an added bonus. This is a multi-sensory extravaganza here. And then I'm going to do some juices. And we've picked pomegranate juice. And again, pomegranate juice, really bright color. And the bright color tells you that there's some interesting chemistry going on. And then also some beet juice. And I wouldn't necessarily suggest drinking the beet juice because it tastes like beets. I guess that's not a huge surprise, but it's an awesome, awesome thing for this particular experiment. And so we have one cup that's going to be our experimental cup and one that's going to be our control cup. And we're going to see how these react to acids and bases. And I'm going to turn it over to Rachel, who's going to come on in and do a little bit of experimenting.
Okay, so our teas are brewed and we're ready to start the experimental phase. What I have here is just household baking soda we bought at the grocery store. Baking soda is a base, which means it's going to release hydroxide, which is one oxygen and one hydrogen with a negative charge. It's going to release hydroxide molecules into the liquids that we've prepared. And those ions are going to react with pigment molecules that come from the plants these liquids were made of. So you can see we're getting a really distinct difference between the control, this is hibiscus tea, between the control and the tea I just added the base to. And what's happening is there's a pigment in this tea called anthocyanin. And when it reacts with the base, the way that anthocyanin interacts with light is affected. And so we're seeing this interesting, really interesting change to this dark bluish color from that original bright reddish purple, and that's the anthocyanin. And turmeric, this is really interesting. Turmeric is actually used, one of the pigment in turmeric, which is called curcumin, actually is used as an acid-base indicator. You can see this molecule, it's going to take a little bit, probably for you to be able to see it a little more. This molecule reacts with the base to give this change to really kind of an interesting orangish brown color. You can see we're getting a noticeable difference between the control, more of a golden yellow, and the experimental. Pomegranate juice, and this is interesting, pomegranate, it's the same molecule as the hibiscus tea, it's anthocyanin. And so we'd expect to see a color change that's similar to what we saw with the hibiscus tea. So let's see what we get. And you'll notice there's some fizzing happening. That's because the pomegranate juice is already acidic. And that's part of the reason we're not testing an acid quite yet, because these juices start out at a relatively acidic pH. And so we're getting a more interesting reaction with a base than with another acid like vinegar. You can see now that it's done, now that the acid in the juice and this base I'm adding have reacted away a little bit, we're starting to see that same dark bluish purple color change that we saw in the hibiscus tea. In the plant world, a lot of the red, purple, blue type colors that you see in fruits and in flowers and in some leaves does come from anthocyanin, this pigment in the hibiscus and the pomegranate juice. But in a few plant groups, a different pigment gives that same deep purple red color. And that's the case for beet juice. That pigment is called betalain. And so let's see what betalain does. You can see that foaming again. You can see this one. The betalain is taking a little longer to change, but as I'm adding this base, we're starting to get a change from that dark red color to distinctly purple.
So Rachel has made some awesome solutions here. And I just want to take a look at them in a little bit more detail. And then we're going to do one more thing. We're going to do a grand finale. So you can see the hibiscus tea started out this pink and has turned to this very dark solution here. The turmeric tea changed from this golden to this kind of like orangey brown color. This is delightful. And that was a change by making it basic. And we got a lovely change in the pomegranate juice as well. And then the beet, subtle, but I like it. I love this color actually here. This is really kind of a nice change. So what Rachel did was she added baking soda, which is sodium bicarbonate, and it turned the solutions mildly basic. Oh, by the way, too, in the baking soda, this is fine. You can eat this. This is not bad. Don't eat spoonfuls of it, but it's not toxic. It's not toxic. Same with the vinegar, not toxic. But I'm going to go ahead. I'm going to add some vinegar to the cups. And the reason I'm going to do that is this. These solutions now are basic. Now the juices certainly started out mildly acidic. If I add a little bit of vinegar to this cup right here, right now it's basic, I'm going to turn it back to being acidic. And when I do that, the color change that happened will reverse. And I'm also going to get a bunch of foam. And what's happening is the acid in the vinegar is reacting with the sodium hydroxide. It's turning it back acidic, and it's also releasing carbon dioxide. This is the classic reaction that people use to make volcanoes and things like that. Now, I used to play with this when I was a kid, and check it out. We are turning it back into its original reddish color. And I'm going a little slow so as not to make it too foamy. But as I add this, I get a return to my original reddish color. And I can tell I'm getting close because as I'm adding more vinegar, I'm not getting the same level of fizz. There we go. And I'm turning it back closer to the original color that I started with. And I'm going to dilute with some water just to see if it's pretty similar. Yeah, so I'm close to where I started. A little bit of a kind of a brownish cast, but I can reverse that reaction. Now let's try the turmeric and see what that does. So again, if I add some vinegar, I'm going to get some foaming because I'm having that reaction with the baking soda. And it's releasing a lot of carbon dioxide. And I will also begin to reverse the color change. And the fizzing is kind of awesome too. And actually in the foam, it's kind of like neat to see the colors. It makes it easier to see what color you have. Oh yes, and I'm starting to see a reversal in the color change. Whoa, that was a little bit too heavy on the vinegar there. Apologies for that. A little bit too heavy. But definitely I've reversed the color so that it's very close to where it started, because I've reversed it from being basic back to being acidic. And I'm going to add a little bit more for good measure. I've already made a terrible mess, so there's very little to lose in a little bit more of a mess, I'm saying. And there we go, pretty much back to where we started again. And now I'm going to take my original sample here and I'm going to add some acid to it, just because when I do that, you can actually see if I make it like totally acid as opposed to neutral, I get a little bit of a color change too. And I would encourage you just to explore and experiment, take brightly colored teas, brightly colored juices, add some baking soda, add some vinegar, and see what kind of color changes you get. And I'm reaching a point where, like, right now, I'm just having fun. And I'm kind of like seeing what happens when I add a little bit of vinegar to this one. It's going to get foamy. And I'm also going to start to see color changes. Oh, and I can see color changes in the foam. Very nice color changes in the foam, actually. So that's kind of an awesome thing. And I'm not going to do too much with these because this one is going to get foamy, and it's also going to get sticky. And I hate to make too much of a mess of our studio. But I can reverse these different reactions. And that's enough of making a mess in our studio today. What we want you to do is we want you to go into the kitchen and find some brightly colored teas, some brightly colored juices, start adding some baking soda, start adding some vinegar, turn them acidic, turn them basic, see what kind of color changes you observe. And just experiment and explore, and that's the Little Shop of Physics way. And if you find something really cool, let us know what you find. Thanks much.